Good afternoon. This is Samuel Jubon and Sean Salmon for Riemann sums. We'll begin with the left-hand sum using the data table above. Uh, to begin, we find the difference of the x values being 2 and 1 times the left data point for f of x being 10. So it would be 2 minus 1 times 10 plus 3 minus 2 times 9, and then 4 minus 3 times 8, and then 5 minus 4 times 7, 6 minus 5 times 6, and you won't actually end up using the f of x equals 5 data point, as we're using our left hand sums. During our right you shall, but right now you will not. As you can see, the x data points all have a difference of 1, so it just end up being 10, 9, 8, 7, and 6, which in turn you add up to get 19 and 21. Adding 19 and 21, you get 40, 40 being your approximate value of the area under the function. Moving on to right hand now, using the same information. So again, we do the x data set 2 minus 1, but this time we multiply by the right f of x data point being 9. So it's the absolute value of 2 minus 1 times 9 plus the absolute value of 3 minus 2 times 8 plus the absolute value of 4 minus 3 times 7 plus the absolute value of 5 minus 4 times 6 plus the absolute value of 6 minus 5 times 5. Once more, the difference in x is 1, so you'll have 9, 8, 7, 6, 5. Once more, as you can see, 7, 6, 5. Then you add those up. Having 6 and 5 is 11. 7 and 8 is 15, and 9 is, of course, 9. 9 and 15 is 24. 24 and 11 is 35. 35 being your answer, the approximation of the area underneath the function using right-hand rule.
Alright, so today we're going to be doing midpoint Riemann sums. Now it's important to note that because doing a midpoint Riemann sum, you're using less subintervals, because if you're using a left or right Riemann sum, you'd be having 8 subintervals going by 2's, but since we're doing midpoint, we're skipping and using 4, therefore it's going to be a less accurate approximation, but it's still very useful in saving time. So you start by jumping through the midpoint for each point, and going all the way down the line of your data set, and then you select the midpoint here, while your y-coordinate will be your height. And it's important to note that if you use each section where you jump from, the 30 minus 10 equals 20, and in this data set, you're lucky because in every scenario, each jump is a distance of 20. Therefore, you can do 20 times your midpoint. Your height will be 11, so you do 20 times 11, plus 50 minus 30 is 20 times 49, plus 70 minus 50 is 20 times 17, and plus 20 times 25. Now, clearly you can take out a 20 to simplify things and make it easier. And when doing this, your answer will come out to be 2040. There you go. Alright, so here we're going to be doing trapezoidal Riemann sums. If you forget what a trapezoid is, it looks like this, kind of like a pancake sort of thing. There's a nice shadow. Alright, so the area of a trapezoid is 1/2 base times h1 plus h2. Here's an example of that. The base is down here at the bottom of the function on the x-coordinate, and then the heights are separate, and they're the y-coordinate. And so basically, essentially what's happening here is that you have the two heights being averaged, so that in the middle it forms like a rectangle, sort of like how the midpoint formula works, so that way you have an entire rectangle that you can calculate the area for. And then over here on the actual graph, what that would look like, you'd have h1, and then you'd have h2. The base is down here, and then it would calculate the midpoint between your two heights here. It's like so, and therefore it's an underestimation because it touches the graph here, and there's a little bit of gap there between where the actual graph is and where the height approximation is. And then so for the data set, the way it's going to work is similar to the midpoint. You're going to take your distance here on the x-plane, and that would be 3, and then that's your base, and then you're going to do 1/2 times h1 plus h2, and since 4 is h1 and 10 is h2, you're just going to average those. That's 14, but you're dividing by 2. Therefore, you're just going to put 7. And then you're going to do the same thing, and it overlaps. So we went from here to here, and then we're going to go from right there from there. Therefore, it's going to be 5 minus 3, which is 2, times the average of 18, which is 9. And then if you just continue this process, 2 times 6 plus 3 times 12 plus 2 times 22.5 plus 3 times 23.5. You plug this fine-looking equation into your trusty graphing calculator, your answer becomes 202.5.